Why, hello and welcome once again to an amazing science lesson. My name is Brett Sieber. I am one of the naturalists for the Three Rivers Park District, located at the Lowry Nature Center in the land of sky blue waters. That's right, in the great state of Minnesota, partnering once again with our friends from Tierney to bring you a lesson today that is about arguably the single most important thing to the existence of life on our planet. So important that when we gaze off into space, when we send things into space in search of other life forms, we're like, all right, we found this other planet, but then the first question, like, sure. But is there blank there? This stuff that's so important you use on a daily basis for cleaning. You use most often on a daily basis for making food. And oh, by the way, it is something that you absolutely have to drink in order to stay alive. That's right. Today is all about water. We're going to talk about the water cycle and how water moves around the planet and where it is spending most of its time. We're going to talk about how much of the actual water that's on the planet is usable by people. And of course, we're going to head outside into my neighborhood in search of where the water is there. Let's get started. All right, so the water that's on the planet has been here from the beginning. It'll always be here, and we can't make more. This is why it's so important that we take care of the water that we have. More on that later. Now, maybe you learned as a first or a second grader the water has three states, like a lot of matter does. A solid, a liquid, and a gas. And it does move through those three states as it moves through the water cycle. I've got a little whiteboard drawing here. We're going to talk about how water moves around the planet. We are going to start right over here with our lake, our ocean, our stream, whatever and wherever it is that water is collecting on the planet. Now, over time, because of the sun, and let's be clear, the sun is what's driving the water cycle all the time. Eventually, the water goes from being a liquid to a gas. We call that evaporation. Once it's up in the air, that's the water highway. It is now being blown all around the planet. Eventually, though, that gas gets cold enough where it goes from a gas back to a liquid. We call that condensation, and it forms those big old white poofy clouds that you see up in the sky. Eventually, those clouds get so full of moisture that it now comes back down to the earth as precipitation. Now, that could be rain, that could be sleet, or that could be what we're having in Minnesota this week. I know, right? Mid-April, still snowing. Yes, it is. Comes back down to the earth. Now, some of that water, when it hits the ground, does absorb down into the ground and goes a couple places. I'll get to that in a moment. Some of it just hits the ground and just runs off back down the hill because of gravity to another collection point. Now, the stuff that ends up on the ground, some of it might trickle down into an underground lake, an aquifer, groundwater, where a lot of us get our drinking water. Some of it goes there. Some of it, however, is absorbed up into the trees, and then out of the tree it goes. You're like, wait, in and then, what is this word right here? When you and I breathe, we call that respiration. When a tree breathes, we call that transpiration. And a tree needs to allow carbon dioxide in. It's one of the things it needs in order to do photosynthesis. When that happens, water comes out and it rejoins in the atmosphere and is part of the cycle. Now, some of that groundwater, that water that trickled down below, does come back up into a collection point through a spring, but all this goes round and round and round. Next, we're going to talk about, all right, so the water cycle exists, so where on the planet is this water and how much of it can we actually use? All right, so before we get into how much of the water on the planet is actually usable by people, I want us to delve a little bit further into where does the water go and how does it travel throughout the water cycle. So what you're going to need for this incredible journey we're about to take, is you're going to need 3 dice. And if you have to go collect dice from different games around your house, make sure that when you're done, you return those dice, because nobody likes opening up the game to play Monopoly to find that the dice are gone. Now, if you don't have dice at your house, that's okay. If you go to the website that's on the screen, random.org, it is completely free. You can click down, scroll, find they have a dice roll generator, random generator, which is exactly what we need. We're going to use 3 dice, and we're going to roll those 3 dice, and you're going to add up the face value on each one. So let's say we roll a 2, a 3, and a 4. Add those up, and you get That's right, you get 9. And you go to my chart here of all the different places you could go as a water molecule. 9 falls between 8 and 12. You are in the clouds. You're going to do this 20 times. Each time you roll those 3 dice, you add it up, you find that number on here, and you figure out whichever it is. If it's the glacier, the river, even the animal, you're like, wait, oh yeah, you know how water gets into and out of an animal. Whatever it is, you write it down. 20 times you're going to do this. And when you're done, you're going to add them all up to figure out where did the water spend the most amount of time, and does that make sense? And if you think about it, it will start to make sense based off of where the water is mostly being held on the planet and how it might get trapped there. You may want to pause the screen, write these down so you can do it. 3 dice, 20 times, add it up, figure out where's water spending the most amount of time. Now, let's figure out how much of it is usable. Alright, so now we know where the water's collecting on the planet. And all those places, from the oceans to the lakes to the rivers to the ground to the animals to the plants to the clouds, all over the place. So how much of that water is actually usable by people? To demonstrate, let us take this container here full of water. Let's pretend for a moment that all of the water on the planet is in this container. Now we know 3/4 of the planet is covered by oceans. Ocean is salt water. We can't use salt water as people. So the amount of water that's fresh water on the planet is about 3%. So that means all this water, see you later, can't use it, left with the fresh water that's in here. Now the fresh water includes the lakes, the rivers, the streams, the ponds, the groundwater, and the glaciers, the ice caps. That stuff is frozen. It's water as a solid. It's locked into place. We can't get at it. So if we remove that from the equation, what we're left with is in here, all of this fresh water, most of the fresh water, mind you, is now off of the table. The stuff that's left, some of it is deep enough in the ground that we can't get to it. Some of it is in such poor shape that we really can't use it. The actual usable, attainable, clean amount of fresh water on the planet that 7.5 billion people are sharing is right about, boom, 1 drop. That's it. This is why it is so important that we take care of the water that we have, because not only are we all relying on it, but we actually, as we learned earlier, can't make more. What I want to do now, if we spent enough time inside, is time to get outside in search of water in my neighborhood. So here we are at a wetland in my neighborhood, actually near my neighborhood. And if you actually scroll just over this way, you'll see a stream that comes through our neighborhood and heads off to a different part of my city. This is that same nearby stream. With all the melting snow, the water is really moving through here. So across the street in a massive parking lot, you can see there is water that is slowly moving across the surface. It is from the melting pile of snow. Now, any water that ends up on a hard surface does become runoff. Now, this water is collected as it runs off down to the end of the parking lot into the storm sewer, where it gets redirected to one of the small nearby holding ponds. A lot of the water that enters those storm sewers ends up in small little teeny tiny ponds like this one. Coming up in 2 weeks, we're going to find out just what's living in this pond here. Well, I want to thank you once again for joining me. I hope you had fun. I hope you learned something as we talked all about the water cycle and how the water that we can't make any more of moves its way around the planet, and just how teeny tiny amount of it is actually stuff that we as people can use. I hope you got out into your neighborhood and explored looking for water and really just have a greater appreciation of the precious resource that it is. Now, if you want more information on the Three Rivers Park District, you can visit our website. If you're looking for more content to go along with the lesson from today, you can visit Tierney's website. My name is Brett Seaburn. Until we see each other again, get outside.